Hi students, how is your preparation for exam? Is going on? We will today discuss about transportation in nutshell. Just we will revise the important topics for SSC JEE 24. So, transportation is having very good weightage for SSC JEE. It is a simple subject, easy subject and easy to get marks, easy to score marks without any complication, without any difficulty. Compared to structural subjects, even in non-structural subjects, the transportation is one of the easiest subject. So, there may be chance of specifications and theory based questions and a little numericals will come. Sometimes numericals may be bouncers also, as calculator is not possible to use in the exam hall. So, you have to be very careful to skip the critical questions sometimes. Coming to the syllabus, it is having highway engineering and railway engineering. Actually, traffic is also comes under highway only. So, in highway engineering we have geometric design and flexible and rigid pavement design and highway materials. In traffic engineering, there may be a chance of 2-3 questions coming into the picture as it is separately given. Now, coming to the railway, only the simple parts of the railway is given here in our syllabus. So, concept of permanent way, sleepers, fixes, track geometry. So, geometric design is main important for us and points and crossing. So, in the present session we will talk about highway completely. We will talk about highway completely. So, coming to the weightage of the exam, now the SSC JEE is completely objective oriented exam. So, you have to prepare in the same way. The level of objective questions will be slightly lower than the SSC, slightly lower than the ESC prelims exam. In ESC prelims exam, you have multiple choice questions, here also multiple choice questions, but level will be very low here. So, it is slightly above the level of local service commission exams and well below ESC prelims exam, because it is SSC junior engineers. Junior engineers is the diploma based level. So, you need to prepare in the same way as that of diploma syllabus. Coming to the weightages, in previously in different sets, the weightage of transportation will be in 2019 if you observe 7, 11, 9, approximately 10 marks you can say, even in 2021 8, 8, 7. So, may be a chance of even now in 2024 there may be a chance of 8 to 10 objective questions from the transportation, 8 to 10 objective questions. It is a good weightage and you can save time here in solving transportation engineering questions. We will look at the simple questions of the SSC JEE, so that you can understand the level of questions and you can prepare the exam. First, coming to the highway development and planning, it comes under geometric design. So, the Indian Road Congress IRC found in the year of, such a year wise things are important for us, especially in highway geometric design and historical development. Actually, Indian Road Congress is offset of JICAR committee. JICAR committee 20 years before independence, that is nothing but 1947 we got independence, 20 years before means 47, 37, 27. So, JICAR has given 3 recommendations mainly. One is CRF, 2 years after independence, 2 years after JICAR committee, 4 years after JICAR committee, 31. Next is IRC is the second recommendation. It is 7 years after the Jaikar committee. 7 years means 27, 28, 29, 30, 31, 32, 33, 34, 1934. Next CRRI is also given by the Jaikar committee, it has given in 1950. 1950 is the year where we got republic. 1950, 26th January, you remember that. So, like that if you remember, these years are very important, 1, 2, 3, 4 you try to remember it. So, presently IRC is 1934, try to remember it as try to remember in a logical manner. Coming to the next question, which of the following can be considered as taking off point in road planning in India? So, road planning started from Nagpur plan, that we call it as the first 20-year plan, first 20-year plan. After that Delhi plan is not there at all. After that Mumbai plan, after that third 20-year plan is Lucknow plan. After this Lucknow plan, the 20-year plans have ceased out. Even sometimes people may ask you the years also. Lucknow plan is ended somewhere in 2001, and 20 years back means 1981, 91, 2001. So, the Mumbai plan, second 20-year plan 1981, 20 years back, that means 81 means 71, 61, 1961 to 81, and Nagpur plan 1961, but it completed in 18 years, just in 18 years it has completed. Actually it has to complete in 1963, but completed in 61. 63 means 20 years, go back 20 years from 63, 63, 53, 43, 1943. In the middle of 1943 and 61, India got independence, people worked a lot and completed the target in just 18 years. Sometime they will ask you these years also, be careful. Lucknow plan ended in 2001. So, first taking off point means first point is Nagpur plan, the first 20-year plan. Next, coming to this question, width of carriageway of a 2-lane road with raised curbs. 2-lane road with raised curbs, generally we use it on what do you say, city roads with footpath, or otherwise we use it over bridges where you have the parapet wall. In that case, the width of 2-lane road is 7.5 meter. Actual 2-lane road width is 7 meter, but here as there is no access to the shoulder, we are using 0.5 meter extra. Now, coming to this question, the side distance is defined as the side distance. We have different type of side distances: stopping, overtaking, intermediate side distance, and headlight side distance. So, what is actually side distance? Length of the roadway a driver can see ahead at any particular time. We go by process of elimination. Read B also, nautical distance for ships. So, side distance is nowhere related to nautical distances and nowhere related to ship, it is on road actually. Length of the runway, it is nowhere related to the airport. Now, coming to the option D, total length of the road to be traversed, nowhere related to surveying. So, if you try to eliminate the 3 options, the best option is option A, length of the roadway a driver can see ahead at any particular point of time. So, actual the clear visible distance ahead of driver for various operations on the road is side distance. Now, coming to this numerical, actually this numerical is a bouncer, takes time to solve it. So, read the question, 2 cars are moving in opposite direction with speeds 25 meter per second and 20 meter per second respectively. The total reaction time of the driver is 2.5 seconds. The quotient of longitudinal friction is 0.35. Then what must be the minimum side distance required to avoid head on collision? 2 cars are moving on the road. One car is moving like this, with a speed of say 25 meter per second, another car coming in the opposite direction with 20 meter per second speed. To avoid accident, both the cars must stop. This car should stop with a distance equal to SSD 1. This car should stop with a distance equal to SSD 2. So, total distance required to avoid head on collision is SSD 1 plus SSD 2. So, SSD 1 is nothing but lag distance plus braking distance, you know, as the speed is given in meter per second, directly you can use Vt plus V square by 2 Gf, lag distance plus braking distance. So, here velocity of the vehicle 1 25, reaction time is given as 2.5 plus 25 square 2 into G, you can round it off to 10 meter per second square. F is given as 0.35. In the same way, for the other vehicle coming in the opposite direction, SSD2 is again same equation, you use it, substitute all the data, but only the velocity is changing here, 2 into 2, 20 into 2.5, 20 square by actual acceleration due to gravity is 9.81, I am using 10 for easy simplification. So, if you simplify it, add it and simplify, it would be okay 258.9. 93 meter. So, answer is option D. But to simplify this without calculator is a nightmare. Okay. Such questions, lengthy questions without calculation, it is difficult to simplify. In that case, you just leave the question, jump to the next question. Now, coming to the next question, as per IRC, what will be the designed stopping side distance in meter for a vehicle of speed 80 km/h on rural highway? This is again memory oriented as per IRC, as per Indian Road Congress. Indian Road Congress has given the SSDs for different speeds that you need to remember. So, that is given in a table form given in IRC 66, 1976. Remembering this table is difficult, but try to remember things like this. Speed 20 km/h, last column, the rounded values of safe stopping side distance, 20 km/h, 20 meter, 25, 25, 30, 30, 40 km/h, slightly different here. For 40 km/h speed, 45 meter is required. For 50 km/h, 60 required, you see. For 60, 80, 65, 90, 80, 120, 100, 180. So, presently what they are asking you is for 80 km/h speed. 80 km/h speed means 120 meter. This value they are asking. So, answer is option C. Very common question. If you have good memory and if you have good space to store these things in your brain, try to by heart. If space is not there, delete the unnecessary things from your brain and try to by heart this, important for exam. Especially in SSC, JEE exam and all, these memory oriented questions are important for us. Which of the following is taken as the highest safe speed limit derived from spot speed study for a highway? So, actually they are asking you safe speed limit is 85th percentile speed. 85th percentile speed is called safe speed. and 98 percentile speed is the design speed. If you want to design a road, we design for 98 percentile speed. If you want to be safe on the road, try to achieve 85 percentile speed, not more than that. And 90 percentile speed and 80 percentile speed is not there at all, but 15 percentile speed is our minimum speed. Try to remember this also. Design speed is 98, safe is 85, minimum is 15. Presently they are asking you safe speed limit in nothing but option A, option America. Now coming to the next question, what is the maximum limit of super elevation as recommended by IRC in hilly area? In hilly roads, maximum super elevation is 10%. This is by IRC. And in plain and rolling terrain, even snow bound hilly terrain, we use 7%. Plain, if the terrain is plain or rolling, or you have snow bound hilly terrain. That means in winter there is a chance of snowfall on the hills. We use 7% as the maximum super elevation limit. Normal South Indian hills where there is no chance of snow, you can go up to 10% as the maximum super elevation. So presently our answer is option Bombay. Coming to the next question, for hill road with the rolling gradient of 6%, the gradient is given. What will be the compensated gradient at the curve of radius 60 meter? They are asking you compensated gradient. First you calculate grade compensation. The grade compensation as per IRC is given by 30 plus R by R, empirical formula it is. Otherwise 75 by R, whichever is least. Radius is 60 meter. So 30 plus 60 is 90 by R, this is 75 by R. So the least will be, this is the least. So we will try to substitute only this here. 75 by 60 is nothing but 75 by 60. Yes, 1.25%. Directly grade compensation comes in percentage. Now compensated gradient is equal to actual gradient minus the grade compensation. Compensated gradient means whatever gradient you want to provide it on the road after compensating it, after giving the discount. Original gradient is 6 minus 1.25, if you deduct, then what will be this? 4.75. They are asking you compensated gradient, it is 4.75%, it is option B. You have to be careful about simplification of this. This you can do it, not a big problem. You can easily calculate within time, without calculator also. You can simplify this without calculator within time. Now coming to the next question, the horizontal highway curve, the width of the highway is 10 meter, width is 10 meter, and the outer edge is 40 centimeter higher with respect to inner edge. Then the super elevation, actually the pavement is rotated like this width is 10 meter, rise is 40 centimeter means 0.4 meter. This is the super elevation. Super elevation is tan theta, slope. Tan theta is 0.4 by 100, 0.4 by 10, otherwise 4 by 100. 4 by 100 is nothing but 425, 1 by 25. 4 1 ja 4, 4 2 ja, and then 5. So the slope is 1 in 25. The super elevation is 1 in 25. The rise of outer edge of the pavement with respect to inner edge, we call it as super elevation. a simple question. Without calculator you can do it. What will be the rolling minimum radius for a horizontal curve of national highway in plain terrain? Assuming design speed is 127 kmph, minimum design speed is 80 kmph, rate of super elevation is 0.05 and quotient of lateral friction is 0.05. So, they are asking you rolling minimum radius. Rolling minimum radius is based on rolling design speed. It is based on rolling design speed. Rolling design speed is nothing but upper limit of speed you can achieve on the road. It is 127 kmph. So, this minimum design speed is not required for us. So, if you want to calculate rolling minimum radius or absolute minimum radius, you need to use 80 kmph or minimum speed. If you want rolling design speed, you need to use upper limit of speed on the road. So, we can use super elevation formula, E plus F is equal to V square by GR small v, as capital V in kmph is given. So, I try to use this version for easy simplification process. Super elevation is 0.05, friction also 0.05 given, nothing but 0.1. 0.1 can be 1 by 10 you can take. V square, V is how much? 127 square, 127 into 127 divided by 127 R. Easy to simplify, you see. This 127 gone, then R will be 127 into 10, 1270 meter. So, what is radius? Option A. Simple question only, but little calculations and little simplifications are required. Okay. Formula also you need to remember. Now, coming to the question on extra widening, it is not on extra widening. Calculate lag distance, it is based on SSD only. Lag distance for a design speed of 47 kmph on a two-way traffic on a single lane road. Assume quotient of friction as this much and reaction time is 2.5. Lag distance, you remember, lag distance is equal to V into T, that is it. So, the quotient of friction is extra data, only to confuse you they have given it, and two-way traffic and two-lane road, these are all extra data given us to confuse. So, the speed here is 47 kmph, you convert into meter per second by multiplying with 5 by 18. 47 into 5 by 18 is now meter per second, into reaction time 2.5 seconds. Simplify, you get the answer. So, it would be 32.64. meter, that is option D. Okay, na? Slight calculations are required here. Now, look at the next question. A vehicle has a wheelbase of 5.5 meter, L is 5.5 meter. What is the off tracking negotiation of a curve with the mean radius 31.5 meter? Take width of pavement 3.5 meter, actually width of the pavement is not required for us. So, off tracking is nothing but W naught, it is L square by 2R just. Off tracking is W naught L square by 2R, mechanical widening is N into L square by 2R. Be careful about it. Off tracking is just L square by 2R, off tracking is N into L square by 2R, where N is number of lanes of the road. L is given as 5.5 into 5.5, 5.5 square, radius is 31.5. you need to simplify. It is around 0.48. Simplification is required. 0.48 is the answer. Answer is option B. Okay, please. Coming to the next question. What is the mechanical extra widening? Nothing but mechanical widening, WM. For a 2-lane, number of lanes are 2. For mechanical widening, number of lanes are required. Mechanical widening is NL square by 2R, N into L square by 2R. Off tracking is just L square by 2R. Pavement width is also not required. Radius of the curve is required. This is extra data, not required for us. Longest wheelbase expected on the road is 5 meter. This is L. Design speed also not required. This is also extra data. Only to confuse you it is given. N is 2 lane, 5 square, 5 into 5 I will take. Radius is 250. If things are given like this, it is easy to simplify without much of difficulty. You see 2 and 2 gets cancelled, 5 1 ja 5, 50, 10, nothing but 1 by 10, nothing but 0.1. Answer is option D. Simple question. Be careful, mechanical widening is NL square by 2R, off tracking is L square by 2R. So, especially to get a good practice, you need to go for the mock tests. ACE is offering mock test exams from 26th May onwards. Mock test exam 26th May 1 p.m. to 3 p.m. It is online mode. For civil mechanical triple E students, the exam will be there. You can just log into the ACE website and then subscribe to this SSC JE mega mock test, and the price is just 100 rupees only, just nominal price. So, with the nominal price, do not think about the money, because to get actual clarity, you require mock tests, you require a test series, because you come to know what is your level, you come to know what are your drawbacks, you come to know what are your negative points, that you can correct it before you go for the main exam. So, try to utilize this opportunity, visit website, it is online mode only, and then registration fees and enroll it. Okay. Exam is on May 24, 26th May 24, 1 p.m. to 3 p.m. Okay. Next we will go to this question. The maximum allowable speed of a vehicle is 20 meter per second and can accelerate 0.25 meter per second square. Then what must be the radius of the circular curve and length of the transition curve? Two things are given, radius of the circular curve and length of the transition curve, such that ratio of the centrifugal force on the vehicle to its weight is 1:4. So, they are asking you two things here. One is radius of the circular curve, so that centrifugal ratio P by W is given as 1/4. Actually, P by W is V square by GR, you remember. Otherwise, V is small v meter per second, as a speed 20 meter per second is given, directly you can substitute. So, V square 20 meter per second into 20 meters per second, G you can take it as 10, radius you can find out 1 by 4. So, radius will be radius of the curve, 4 goes here, 0 0 cancels, 20 into 2 into 4, 8 into 2, 160 meter. With the radius, is there any chance to pick up the answer? So, here 160 is there, 160 is there, 2 options you can eliminate. Now, length of the transition curve is equal to V cube by CR. V cube, V is 20, 20 into 20. What is C given? 0.25. It is actually rate of change of centrifugal acceleration. It is not acceleration, rate of change of acceleration in meter per second cube it should be, but in the exam it is given as 0.25 meter per second square. Actually it should be meter per second cube, it rate of change of centrifugal acceleration. Radius whatever you have calculated previously, that you substitute. So, what will be the answer? Try to simplify. 0 0 gone, 2 8 10 4 again 10 2. Nothing but 100. 0.25 can be written as 25 by 100 into 2. 25 into 2 is 50. 50 by 100. You can simplify now. 50 1 ja 2 ja. So, 200. LS will be answer, you can pick it up now, 200 meter, 160 meter. With only 160 it is not possible to pick up the answer. Even though question seems to be lengthy, simplification is easy, not that difficult. Even I am simplifying means you can definitely do it. Okay, simplification is easy here. Time taking, you have to get the speed with the practice. The practice generally comes with the test series and all. Now, coming to this next question, which of the following curves fulfill the requirement of an ideal transition? Ideal transition as per IRC is spiral curve, spiral or clothoid or Glover spiral is ideal transition for highways. For highways, ideal transition is spiral. For railway, ideal transition is cubic parabola. Cubic parabola is ideal for railways. You need to read the question properly and then pick up the answer. For railways, ideal transition is cubic parabola. For highway, ideal transition is spiral. Look at the question. 2-lane road with a design speed is given, has a horizontal curve of radius 400 meter. What will be the super elevation required to be provided with the mixed traffic? Mixed traffic means it is a design super elevation, please. Mixed traffic is design super elevation. Especially in design, what IRC says is you need to use 75% of the speed must be balanced by the super elevation. This is small v, 0.75 v small v whole square by gr. Otherwise, if you convert this into kmph, it is v square by 225 r. So, substitute these values. V is 60, so 60 into 60 by 225, radius of the curve is 400. if you simplify, 0 zeros you can cut, 0 0 0 0 you can cut, 3 ja, 2 2 ja, 2 1 ja, 3 ja, 225 is there, is 0.04, nothing but 4%. Answer is option B. Okay, slight critical in the simplification here. Now, coming to this question on summit curves, there are two gradients, G1 is 1.2, G2 is downward minus 0.8 gradient, deflection angle is algebraic difference of the two gradients plus 1.2 minus 0.08. The deflection angle is 2% then, minus of minus is plus. They are saying that rate of change of gradient 0.1% of gradient 20 meter is equal to 1 chain. Point 1% gradient 1 chain, 1% gradient 10 chains, 2% gradient there is we have 2% gradient, for 2% gradient 20 chains. So, 20 chain length will be our length of the curve, summit curve. Okay, simple interpolation. Look at the question. The test commonly adopted to determine the grade of bitumen in terms of hardness is. So, the grade especially with the hardness is the penetration grade, which can be calculated based upon the penetration test. There is another gradation called viscosity grade, that is based upon the resistance to flow. So, based upon the hardness, gradation is given with the help of penetration test, a direct question. Next, identify the test to be conducted for determination of modulus of subgrade reaction. Modulus of subgrade reaction can be by plate load test or plate bearing test. Modulus of subgrade reaction and Eng's modulus of the soil can be calculated by the plate load test. Even bearing capacity can also be calculated by plate load test. Through plate load test or plate bearing test, you can calculate bearing capacity, modulus of subgrade reaction and Eng's modulus of the subgrade soil. Now, coming to this question, according to Indian Road Congress, flakiness index should not exceed 10%. Flakiness index should not be more than 10%. And according to IRC, what should be the maximum stripping value of aggregate used in bituminous concrete construction? Maximum value of stripping value of the aggregate will be 25% as per IRC. Maximum is 25, should not be more than 25 at any cost. Which of the following is not a critical parameter to control cracking and rutting of flexible pavement? Cracking is due to fatigue action. So, they are saying that fatigue plus rutting. Fatigue is based on tensile strain on the bottom of bituminous layer. So, which of the following is not a critical parameter? Vertical subgrade strain is responsible for rutting. Vertical subbase strain we do not consider anywhere. Tensile strain near the surface close to the edge of the wheel tensile strain at the bottom of the bituminous layer we will consider in fatigue action. So, vertical subbase strain we do not consider. So, answer is option B, whichever is not considered, not considered for fatigue plus rutting. Good to the next question. What nature of warping stress are generated in reinforced cement concrete pavement during summer midday? During summer midday, temperature on the top will be high compared to the temperature on the bottom. So, the pavement warps like this. Pavement wants to warp like this due to heavy heat of the sun rays. Top layer is experiencing more temperature compared to the bottom layer. So, top layer length becomes more than the bottom layer's length. So, pavement wants to warp like this, but the sulphate of the pavement prevents this warping. The sulphate says I do not allow, it presses back to the original position. Once it presses back to the original position, what happens is the stress on the bottom is tension, top is compression. So, on the bottom of the slab will be under tension, top will be under compression. So, what is the answer? Compressive stress, tensile in bottom fiber and compressive in top fiber. Do not say that RSR this is something like hogging, tension top, compression bottom, it is not like that. Pavement wants to warp like this, but the sulphate is preventing that warping. If there is no sulphate, pavement wants to warp like this and there is no stress, but sulphate prevents. That is why bottom is under tension, top is under compression. So, nature of stresses because of temperature and warping will be opposite to that of actual stresses whatever you experience by direct loading. This point you try to remember. Due to warping, pavement wants to warp like this, but sulphate is stopping. As sulphate is prevented warping, we will get stresses. So, tension bottom, top compression. Now, coming to this question, the order of the components of typical flexible pavement from bottom to top. Bottom we have subgrade, then top we have, so here granular base, granular subbase, this is no way, this is no way. Bottom most is subgrade, bottom most subgrade. Answer is either C or D. After subgrade you have granular base course, granular subbase course actually. So, this is correct, this granular subbase is wrong. So, granular subbase will be there, this works as a drainage plus filter layer. Over that granular base course, over that bituminous binder course and then surface course. This is correct. Sequence Delhi is correct. So, over the subgrade soil we have granular subbase and then base, then wearing course comprising of two layers. One is binder course on the lower part, upper course is surface finishing part. Come to this next question. 8 meter wide bituminous concrete pavement of a state highway is to be constructed on heavy rainfall region. What should be the height of the crown with respect to edges if the cross fall is 1 in 50? So, cross fall is nothing but camber is 1 in 50. Assume that pavement is like this. What is the total width of the pavement? 8 meter. Here to here is 8 meter. What is the central rise? What should be this rise they are asking? If the slope is 1 in 50. If if you take this triangle, this is 4 meter, slope is nothing but tan theta, nothing but here camber, is equal to what is given, 1 by 50 is given. Presently from our triangle, opposite by adjacent, y by 4 meter. Simplify and give me what is y, 4 meter by 50. How much? 4 by 50, 2 2 ja 225. One by 12.5. 1 by 12.5. 1 by 12.5 is 0.08. Like this. So, answer is 0.08 meter. Simplification requires little time here. Okay. Come to the next question. This is from traffic engineering. Red light is used as a signal for stop, as it is visible from greater distance. Generally, red is visible from a long distance than other colors because of its, actually speaking, it's you can look at this next slide. You see here, this is the spectrum with GR. Our V, I, B, G, Y, O, R, 7 color, 1, 2, 3, 4, 5, 6, 7, 7 colors, starting with violet and red. If you look at the wavelength, the red is having high wavelength, 750 nanometer, violet is having 380 nanometer, less and very high, and less than violet we call it as ultraviolet, more than red we call it as infrared rays. Infrared rays are dangerous, ultraviolet also dangerous. So, these colors are okay. Now, coming to the options, red is having high wavelength, red is having longest wavelength, red is having longest wavelength and low frequency, not high frequency. If wavelength is high, frequency will be low compared to any other color in the visible spectrum. So, answer is C. If wavelength is high, frequency will be low frequency. Okay, okay. Important question. Come to the next question. In India, yellow and white color are milestones, milestone colors, milestones whatever you see, milestone blocks whatever you see by the side of road, yellow and white combination. You might have observed various milestone combinations. You see here, yellow and white milestone combination comes in national highways, green and white state highways, black and white in city roads or district roads, red and white in rural roads, especially in Pradhan Mantri Gram Sadak Yojana. So, yellow and white they are asking you, it is national highway, yellow and white is national highways. Look at the next question. In which type of traffic signaling system do signals along a given road shows the same indication? Same indication means along a road, if you observe, there are so many junctions. At all the junctions you have the same color. Say here red is there, here also red, here also red, here also red. After some time if it is yellow, everywhere yellow. After some time if it is green, everywhere green. With single switch you can control all the signals at once, that we call it as simultaneous system. Simultaneously you can control, at the same time you can control all the signals of that particular street. Alternate means here red, next is green, next red, next is green, like that alternate will be there, that is called alternative system. So, simultaneous system is most inefficient system, easy to control is always inefficient system. If you are easy going person, you are inefficient person, like that simultaneous system is easy to operate, easy to control, but not efficient at all. Now, coming to this next question, which type of transportation survey? The vehicles are stopped on a sampling basis and information is collected. Vehicles are stopped and then information is collected, not taxi survey. Tax on vehicle, if tax are there on vehicles like fast tag, there is no need to stop, vehicle can be scanned and go away. Registration number plate survey, just by looking at the number plate from a distance without stopping the vehicles, you can note down the registration number and allow the vehicle to go. So, no need to stop the vehicle in registration number plate survey. Roadside interview method, in roadside interview survey you need to stop the vehicle and ask the driver and passengers that how is your journey, how is your road, how do you feel, like that you can ask questions. There you need to stop the vehicles. So, answer is option D, all other options are not correct. Just by process of elimination you can pick up the right option. Now, you see here, select the correct match of the signals. Regulatory signs, nothing but mandatory signs, compulsory signs. You must compulsorily follow. Like prohibitory signs. Prohibitory signs means right turn prohibited, left turn prohibited, U-turn prohibited, you must compulsorily follow. Right turn prohibited, if you take a right turn, then police will come and fine you, that is mandatory. So, one should match with A, one should match with A, oh, 3 options it is there. Next, warning sign, warning sign just gives you warning, like cross road ahead, side road ahead, narrow bridge ahead, that gives you just warning, warning that there is a narrow bridge ahead, driver feels alert with this. So, 2 should match with B, 2 should match with B means this is wrong, this is also wrong, only you have this option. Let us see informatory sign is correctly matching or not. Information sign, parking signs, parking right side, yes, that is an information. If you want to park, you can park it, otherwise you can go ahead. Flood gauges, flood gauges means flood level in a rainy season, that is information. If flood level is up to certain height and if you park your vehicle there and go away, and if suddenly flood comes, your vehicle may also flooded away. So, facilitation information like hospital ahead, telephone booth ahead, these are all facilities that will be informed. No need to read, that just gives you information. So, correct, 3 is matching with C only. Answer is option D. By process of elimination, theory questions can be picked up with the right answer. Now, look at this question. For computation of average daily traffic, minimum number of days of continuous traffic count made at the location. For average daily traffic, average, if you want average, minimum 2 days of traffic data is required, minimum 2 days. They are asking you minimum number of days. To get average, we require at least 2 values. With single value you can't take average. Anything minimum 2 values, anything more than any infinite values, okay, not a problem. So, to get an average, we require minimum 2 values. Easy question, logically you can pick up the answer. Now, coming to the next question, regulatory signs are generally circular in shape, especially stops, speed limit sign, all these regulatory or mandatory signs are circular in shape, except stop sign and give way sign. Stop sign is octagonal, give way sign is inverted triangle, which is not in circular shape. Okay. No parking is in circular, restriction end sign is circular, stop sign is not circular, it is octagonal. Speed limit sign also circular. So, answer is not circular, answer is option C. Stop sign is octagonal. There is one more regulatory sign which is not circular is give way sign, that is inverted triangle. Right angle two lane road intersection with the two-way traffic, the total number of potential conflicts for two lane two-way is 24. Memory oriented question. So, in case of two roads meeting, one lane is two-way, one lane is one-way, then number of potential conflicts are 11. If both the roads are one-way, potential conflicts are 6. If both the roads are one-way, potential conflicts are 6. One road is one-way, one road is two-way, potential conflicts are 11. Both the roads are two-way is 24. Try to remember this. So, these are all a type of probable questions which may come in SSC JE. We have just gone through the things in brief. So, similar questions you need to practice, especially here what you need to observe is speed is required, accuracy is required, read the question properly, answer the question sometimes with process of elimination. So, these points are important for your success. Try to follow the things, practice number of questions, take many test series. Definitely with improved speed you can achieve the target whatever you want. I wish you all the best. Thank you very much for your patience.